It's called a direct air calorimeter. It's the only one in the world, and what it does is it allows us to make really precise measurements of how much heat the body's losing. The way it works is we measure temperature entering a small chamber and then the temperature exiting, and we also measure the humidity entering the room and also exiting the room. So from those measurements we can calculate how much heat the body is losing. We can also measure metabolic rate with what's called an indirect calorimetry, so it's kind of a metabolic mass, and from the difference between the metabolic heat production and the heat we lose via sweating, we can then calculate how much heat is being stored within the body. The reason why that's really important is because often measurements of core temperature are not always precisely reflecting how much heat is being stored in the body. And that allows us to answer some really unique questions and also get a better sense of why certain individuals respond differently to thermal stress. So what you might see during a heat wave is that over the course of an hour we may not see much of a change in our body temperature. But what's actually happening is the body's progressively storing heat during that time. That's why I think we often see some of those effects of a heat wave that tend to be within several days after the heat wave is actually hit. So it's usually 2 to 3 days afterwards we see kind of the most dangerous conditions.